In today's video, we're going to be building the first iteration of my 7-inch quadcopter here. Now, this is an FPV quadcopter, and what I'm aiming with this build is to get the longest flight time possible. With our first iteration here, it's just going to be basically just the motors getting replaced and the battery sizes. So I decided to go with these motors here. And at the same time, I wanted to keep everything as budget as possible because usually things of this nature don't pull a lot of amperage, and that's why they're efficient. So you don't really need a super heavy load ESC. So this is going to be a beginner guide. This will help you basically build any other quadcopter if you follow the same steps. Now we're going to talk about every single component here and why I chose these components. And I'm going to cover just about everything. And if there were some issues to arise, we'll cover those together and hopefully help you get over those. And before we get into that, a quick word from our sponsor. So the sponsor of today's video is Skillshare, and this is really great timing because this will get you your introduction into Python for my upcoming videos, where I'll be teaching you how to create your own AI or train your own AI and set up the environments in order to get cracking at it. Now you will need some basic Python in order to get going, creating your reward systems and any other kind of thing you might want to do there once I start the tutorial. And not only that, the first 1,000 signups that use the links below will get a free premium membership, and that will open you to so many other classes. You have so many things to go through. We have web development, applied control systems for engineering, PID controllers, so many crazy cool things, social media stuff, photography things that I'm just barely scratching the surface. So make sure you check the links down below. And again, huge shout out to Skillshare for sponsoring this video. And with that being said, let's go ahead and jump to the video. So let's discuss the components here. So for frame, what we're going to be using is the GETFPV Mark IV 7-inch variant. This is my third GETFPV Mark IV. I have the 5-inch, also the 5-inch HD, and I also do have this 7-inch, which I really want to build. Now, if we move to the motors here, these are basically T-motor, but they're Racer Star Air 2508 1700 kV. So there's a 1200 kV variant of this that'll run 7-inch propellers. However, this one is not currently recommended on 7-inch propellers, but I want to do a 6-inch setup and also a 5-inch setup with this, with some lithium ion packs and see how well that does. So I'm going to be playing around with the KVs. I also have the 1200 on the way and also the new T-motor 1300 KVs. So it's going to be an experimental quadcopter here. As it stands right now, this is going to be a pretty great quadcopter. So I just really want to find the best or optimal setup to get the longest flight time, yet also still have power and durability as well. So next thing down the line, we're going to talk about the stack. Now, if you don't know what a stack is, basically a stack is referred to the ESC and the flight control. These are the main components of the quadcopter. The ESC is in charge of delivering the power and also controlling the motors. However, the flight controller tells the motors what to do, like tells the ESC, then the ESC does that to the motor, and that's what these are for. So this is the main brain of the operation, and this is the thing that delivers the power to the motors and have them move accordingly. So this stack is called the iFlex XXE, and this is one of the cheapest stacks out there. And don't let the cheapness fool you. It is a budget stack for around 50 bucks from a well-known company here. And I've decided to go with this stack to keep the overall price down. So it's going to be very easy to replace. The parts are readily available, and you could just quickly purchase them. You could even purchase two for the price of a stack from another company. And this is going to do the job just fine for this setup here. Now for video transmitter, what I'm going to go with right now is the Aikin TX805. These are pretty cheap. They're around 12 bucks and they perform really great. This is not the first one I've ever used. They have pretty much everything you need. You have your MMCX, which is the latest tech in VTX antennas, if you might say. And we also do have smart audio, which will allow us to change the channel and everything through our remote instead of having to come here and press the button, which will be very useful when you're out in the field. And again, everything is linked down below here. You go ahead, check them out. And I also do have coupons for you guys. So make sure you check the links down below. Now for antenna, I've decided to go with Rush FPV. These are by far some of the best antennas. And when you buy a pack, you actually get 2 in them. And just make sure you get the correct connector type. As you can tell, this is called MMCX. And that's just going to go in just like that, which is really nice, and it can still spin. Now, what's really nice about these is not only they give you 2 video transmitter antennas from Rush FPV, they actually come in a box like this right here. They also do provide you with these plastic pieces, and if your frame it could accommodate these, you'll be able to stick it in just like that. So let me just actually pop this over for you. And you can see where it fits right there. The frame had a hole and I was able to screw those in. Now, if we grab a look at the plastic part here, if you take a closer look, you'll see that there's a nut-shaped cutout right there. And they do provide you with the nuts. You stick them in here and then you just flip it over and you allow the screw to go through the frame, and that'll hold absolutely gorgeous. And that's what we see. That's what we see going on here. When I take out the frame, I will show you that up close in a bit here. So this is what I'm using. I'm actually still left with these two. That one's over there on the quadcopter. For camera, I'm using the Runcam Eagle 3. There are cheaper variants, but this is going to have really great quality. And I still prefer to fly analog more than HD. So this is going to do the job just fine. Also linked down below, some other cheaper variants from Runcam are also down below. Now also, if you take a closer look at my motor wirings here, you can see I have this little wrap going on for them. Well, I picked this up from RJX Hobby. Again, it'll be linked down below. You get a huge roll that'll last you for a ton of quadcopters here. And it's just going to make the overall, it's going to protect the motor wires. That's one thing. And it's going to make the overall build much cleaner. As you can tell already how I've had that set up right there. 2 pieces of tape, and then the motor wires are inside, and it just keeps it very, very nice. Now let's go ahead and move on to tools. So for solder, I usually use this one. I don't know if you'll be able to find it, but in Europe you should be able to. It's basically a 6040 with 2% flux, and it's 8 millimeters in diameter, and usually that gets the job done for me. I usually get these from Tesco, so if you live in Europe, you know where Tesco is. That's where I usually pick this up. For other tools, you are going to need hex driver kits. These are very cheap, but very, very useful, because if you have cheap hex drivers and you strip a screw on your frame, that could be a nightmare to get out. You could possibly even ruin your frame. So it's really good to invest in these. They always come in handy. There's many things that use hex driver. They usually come in a set of 4 or 5. I'll have some linked down below. I've had these for almost 3 years now, and absolutely insane. Some tweezers, you don't need it, but it's really good. And a little nice tool, if you were to have this tool, it's called a hemostat, I think. And that'll help you solder in your battery connector, because the wire gets really, really hot. And this will allow it to kind of lock into place. So right now it has locked into place right there. And I could just grab this and then go ahead and solder without worrying about burning my finger. So it can be very useful at times. Also some wire cutters and a soldering station. Doesn't matter, just one that could output some pretty decent power. I'll have mine linked down below. I'm actually using a $50 soldering station, even though I have big solder stations that cost over $200-300. But I've been using this because it just fits on my desk. I'll have that one linked down below. I highly recommend it, and we're going to be using it for this build. So with that being said, let's go ahead and start off with the flight controller. So the first tip that I always like to do first is identify all the pads that I'm going to need on the flight controller and begin soldering everything that's going to go to the flight controller. For example, we only have a couple things here: the camera, the receiver, and also the video transmitter. Those are the only things that's really going to be connected to the flight controller, other than the ESC, which nowadays usually just connects with a connector and you're good to go. So this makes our life so much more easier. So let's go ahead and identify the pads that we're going to be using for this flight controller here. So first of all, let's start with the camera. So for the camera, what we're going to be looking for is a 5 volt, a ground, and a video input. And it's the same usually on every other flight controller as well. Those are the main pads. So here's our VI, which is going to be considered video input. Then the next one over is actually 5 volts. So I'll zoom in a little bit there. So the next one over is going to be 5 volt. So that's going to be our power for our camera. And the last one right there on the last side right there is going to be the ground. And that's really it for the camera. We'll go ahead and solder that in a bit here. On the bottom of it, what's really nice with this layout is we have the video transmitter part as well. So if we take a closer look here, we have another ground, which is what we're going to need for power. Then we have BAT, which means battery voltage. And the next one over is going to be VO, which is basically video output, because the video signal has to go in through the flight controller in order to overlay the useful information, such as your battery voltage, your current, your GPS location if you had a GPS. And if you take a closer look here, we have one extra one right there that says T1. And that's going to be used for that thing called smart audio. It's the protocol that allows you to change the channel and the power of the video transmitter without the need of you going and pressing the button. And just like that, we have those set up. So now we're going to do the receiver. Now the receiver is very important because you need to know what kind of receiver you have. There's only basically 2 in the market. We have actually 3, but more likely you probably have one of these 2. If you have the third one, then you know what you're doing. So there's an S-bus and an I-bus. I-bus can basically go almost anywhere, and S-bus has to go to specific pad, especially on F4 flight controllers like this one here. So in our case, we do have an F4 flight controller and we have an S-bus receiver. And here, the place where it's going to go is going to go to the NR2 pad right there. That's where our signal is going to go. And the reason it's going to go there because this is an inverted signal pad. So because S-Bus talks invertedly and the F4s don't know how to understand it. So there's a special circuit right here on the side that inverts that for you. So we're getting a little bit too advanced here. But anyways, here is going to be our pad for S-Bus. If you had I-Bus, you can use, for example, R1 or whatever other one you could find here that's not inverted. You could also use R2 right there. This is the inverted R2. This is the normal R2. So I-Bus would go to normal. And we have the S-Bus, which is going to go to the NR2. And then we're going to need power like anything else. So we'll take the ground from right here. Just make our life a little bit easier. Usually ground pads are a little bit more difficult to solder onto because they dissipate heat much better because the copper traces are all over the board. And then above that, we have the 5 volt, which is going to give us 5 volt for our receiver here. So here's our current receiver, which is going to be an XM Plus radio. Here we have our S-Bus signal. Red is going to be 5 volt and black is going to be the ground. So let's go ahead and prepare those. Now with silicone wires, usually wire cutters don't do the trick. So the best way to do it is just basically pinch it and then just pull, and then you'll be good to go most of the time, just like that. And then we're going to go ahead and twist it. And I recommend you do this on every single wire. Definitely recommend twisting the wire because when you start soldering, you don't want a strand to pop out and then create a short circuit, and you could burn you could burn just about every single electronic on the board. So you just got to be very, very careful, and that's why I highly recommend you twist them after you strip them. So now that I've stripped all 3 wires, I'm going to go ahead and grab my solder. Make sure you move your flight controller away. Now it's currently levitating in the air, just like that. And that's what's really nice about solder is it stays in its position here. And all we got to do is just touch these 2 together, just like that. There we go. That's good. Hopefully you guys can see that. And just like that, just a little bit is going to be fine. And here we go, just a tiny bit. Now we're going to go ahead and just shorten these out a little bit more because they're a bit too long in my opinion. Make sure you cut those extra pieces far away from your electronics and also your motors because you don't want them to fall on something and short circuit once you boot this guy up. So now we're going to go ahead and start soldering in the receiver. Now, a tip if you don't know this, it's really good to rest your forearms on the edge of the table. And this way you have more control instead of having your arm levitating because you'll keep shaking like that. So resting your forearms on the table is going to be really great. And also if you're right-handed, start from the left side. So as you can tell, we have a left one and a right one. So start from the left and move to the right. It's going to be better. So always move towards your dominant hand here. And in this case, we also have one up here. So we could kind of think of it like that. It'll be much easier for us to solder this way. So we could start with the 5 volt, for example, this top one here. And we're just going to go ahead and grab our wire. Make sure the tip is always shiny of the soldering iron. So I'm just going to go ahead and add some solder and clean it off. Because the shinier it is, the more heat will transfer. It'll transfer the heat much better, thus making everything so much more easy to solder to. So there we go. We have this set up here. And I'm going to start by heating up the pad, bring the wire, and just touch both of them together. Now my soldering isn't going to be the greatest because I'm sacrificing my view for you guys. So the camera is priority here, and I'm pretty far away actually. There we go. So now we have our 5 volt into place. Really nice. Make sure it's not touching anything. Next was the, I think, ground. Yep, so we're going to go ahead and do ground. Again, we're starting from the left and moving right just because it just makes everything so much more easier. Okay, we're going to heat up the pad first. And then both of them together, just like that. And last but not least is going to be our signal, which is on R2. Now, I highly recommend you go grab yourself a sticky note or a piece of paper and you write down receiver R2. Because that's going to play a big role when you're going to go and set everything up with your inside Betaflight, basically. So there we go. We're going to keep that like that for now. So now our receiver is complete. Let's go ahead and jump to the video transmitter part. So we'll do the video transmitter, then we'll go ahead and do the camera. All right, so now we're going to go ahead and jump into the video transmitter part. So you need to take into consideration a couple things. Now, some video transmitter have an extra 5 volt output, which you'll have an extra 5 volt in ground, like in our case here. I've cut those off, and the reason why they put those there is usually people who have RC wings would use the video transmitter to power up their camera, but in our case we use the flight controller because the camera has to go through the flight controller in order for this chip to overlay the information that we need, so we know when to land and we know we just get a bunch of useful information here. So you always want to take a look at, and it'll tell you the input. So we have 7 to 24 input. ground. So that's going to be our power for our video transmitter, which is going to be these two wires right there. And then we have video, which is the third one, the yellow one. Usually video is always yellow. And smart audio or IRC tram protocol, whatever it might be, they're going to be connected in the same position. So here we have smart audio, and that's going to go to that T pad. So let's go ahead and do this. I've already stripped and soldered the wires here, so we can go ahead and start soldering. So in our case here, what we have is T1 is first. So we're going to take the smart audio, or it might be IRC tram protocol for your receiver here. So let's go ahead and set that up. So I like to heat up the pad first. And as you can tell, I'm not soldering it this way. And the reason for that is because this is the front and the video transmitter is going to be in the back, and it's going to be barely enough wire. So soldering it this way is going to be much better for us. So let's go ahead and start with this. I'm going to twist it over just to make it a little bit easier for me here. And I'm going to go ahead and hit it right there. So I'm going to heat up the pad, then bring the wire, and it should be good. There we go. We have our first one. Now next one over is VO, which means video output. So we're going to solder the yellow wire from the video transmitter on that. Okay, that's good. Next one over was the BAT, which means battery voltage. So it's going to be the red wire, which is the power input for the video transmitter. And the last one is going to be ground, which is usually the black wire here. So let's just prepare. Usually ground takes a little bit to heat up. Just give it a bit and then just wait for it. Can be kind of annoying. If it's too annoying for you, add a bit of solder. And if it's still too annoying, then increase your temperature slightly. And now that looks pretty good. I'm very satisfied with that. Nothing is touching and nothing should theoretically touch at all. So now we're done with our receiver and also our video transmitter. The next thing we want to do is the camera. Now what's really nice about the camera is the wires provided. However, not all camera wires are the same, but they all carry the same exact 3 wires you're going to need, which are the black, yellow, and red one. Anything else you could ignore for now. Later on when you get more advanced, you could use them, but not all people use them anyways, like the on-screen display. But I'm not going to get too far into that in this video. So now I've gone ahead and plugged in the connector, and we can see that the first one says 5 volt or 5 to 36 volts. Then we have ground, then we have video. So we're going to put this on the 5 volt. Might be a little bit difficult to see. There you go. So the red wire is going to be 5 volt, black is going to be ground, and the yellow wire is going to be video. And if we take a closer look here, we have the one right on the right is ground, then 5 volt, and then VI, which is video input. So let's go ahead and cut this connector and start setting it up. So I'm just going to trim off the wires just like that. So now what I'm going to do is strip and twist them, and I'll be right back, and we'll go ahead and solder these up together. All right, so now we have our camera wires prepared, so let's go ahead and start soldering. So we have the one all the way on the left there is going to be ground, and that's what I'm going to start off with here. So I'm going to heat up the pad and then bring in the wire and just heat both of them up together. There we go. Wait a bit before you move so you get a clean joint. Again, I'm going to heat up the 5 volt, bring in the wire. The wire can get pretty hot, so just be really careful. So there we go. That looks good, I think. I can't see, it's really far. No, actually, it's not good. I don't like that. I'm just going to move it a little bit more. There we go. And the last one's going to be the video input, which is going to be the camera signal wire. Maybe we should have trimmed that wire a little bit more. I think we can get away with it. Let's just double check everything up close. Yeah, everything looks really, really nice. I'm very satisfied with how that came out. So now we're basically done with the flight controller. So the next thing I want to do now is I'm going to go ahead and grab my frame. I'm going to put the ESC into place here, and then we could take it from there. So now we're going to be jumping into soldering the ESC. So go grab yourself a coffee or something, because this can take some time. Not in the fact that how many wires you have to solder. If you're new, it can be kind of tricky. So stay with me. I'll give you some tips and tricks and stuff to get you going here. Now, the first thing you want to make sure of when you install the ESC is very important. The numbers. They do have numbers on there. For example, this one you can see M1, M2, M3, and M4. It's very important you set it up correctly, and I'll tell you how, because if you don't, your thing will never fly unless you know what you're doing. So the way that the Betaflight code works, the firmware that we use on our flight controller, motor 1 is the back right motor. So this is where the camera would go. So motor 1, motor 2, motor 3, and then it's motor 4. So 1, 2, 3, 4. And that's what we see here. 1, 2, 3, 4. Now, you might have to flip yours over or turn it around. Depending on yours, just make sure you take a note of that. Now, when you cut the motor wires into length here, because some of them might be really long like mine were, what you want to do, it's a nice way to do it. This is how I do it really quickly, is I grab the motor wires and I make them run to the last solder point from the other side of where the motor is coming from, or the motor wires are coming from. And I cut it there. And same thing, I would grab this one and I'd hold it there and I would cut it there. And that gives me enough playroom to get everything correctly here. Once you do that, you want to go ahead, strip, make sure you twist the living hell out of them, and then put solder on the wires. Because if one strand is popping up to the next one, you could fry your motor and or your ESC, and you do not want that. So keep that in mind here. Now also, a lot of questions I get is, where do these wires go? Well, the most important thing right now is to have them basically in the same quadrant. So we have 3, 3, 3, 3. You don't want to put one motor wire from this motor up here to the 3 down here, or else you're screwed. So make sure you do the first 3, which would go to this motor. Then those 3 would go to that. These 3 would go to this, and that 3 would go to that. And it doesn't matter the orientation of these 3 where you put them, because we could always go back and change the way that the motor is spinning inside the software. So the most important thing is just to get them in the correct quadrant. That's all that matters right now. So let's go ahead and get started. So what you want to do first is you want to actually increase your temperature. Now, for example, I'm using lead solder, and it's usually around 350 degrees Celsius. So I usually put mine around 400 to 410 degrees Celsius. It just makes your life so much easier. Now, as you can tell, I already have solder. It's because I noise tested this on the channel, but it's okay. We're going to refreshen this solder up, and it's going to be the same concept for you as well. What you want to do first is you want to come in, you want to hold, actually what's better is let's do it outside the quadcopter right now, because we really don't need it inside. Before you place your ESC down, make sure there's no wire strands anywhere below it so it doesn't stick to it and then you get screwed later on. So that's very important. All right, so this pad down here is silicone. I really recommend this. I'll have it linked down below. This is what I solder everything onto. It's heat resistant, so nothing could really happen. So that's really great. And it provides anti-slip properties, which again is a huge benefit as well. So the first thing you want to do is make sure your soldering tip is very shiny, as shiny as possible, because that'll allow the heat to transfer better. Then you want to go ahead and just keep your tip on the motor pad for a while, for a bit. And then start bringing in the solder, and then boom, just like that. Look at that, very beautiful. And then again, we're gonna do it here. There we go, I could feel the pad now. Now I'm moving my soldering iron back and forth because then once I get to feel the pad, then I know I'm all the way down touching the pad. Now if you already, yours, obviously you'll be touching the pad immediately, but since I have solder, that's what I'm doing here. Alrighty, sorry about that message. It was Discord. And if you do have any issues, download Ask FPV app. It's linked down below. There's iOS and Android version, which I've created, where the community actually goes and helps each other out there. And also check out fpvconnect.app. It's a social media platform for FPV pilots, and I'm hosting a lot of competitions this month and every other month that's upcoming, sponsored by the companies themselves. So it's going to be a really nice place to go and get some free stuff. You could win, you have nothing to lose, you just post a video, and if your video gets a lot of likes, then you're more likely going to win. So let's go ahead and add solder here. Now some ESCs, when you're adding solder to them, you got to be very careful, especially if they have holes where the pads are, because it could seep to the other side. So you want to be very, very careful. So for example, here we had a little bit going on there, and this could be very dangerous because if the ESC is so low down, it touches the carbon fiber. If both of these touch the carbon fiber, then you'd have a short circuit. Right now, I let gravity pull it back down to the other way, as you can kind of tell right there. So that's what I did right there. And I highly recommend, I think we should start out with our battery leads here. So that's, I think we should do that as well. So let's go ahead and start with the battery power. Now, usually you would have a low ESR capacitor. I'd highly recommend you install that. I lost mine for this one. So we're going to run this without a low ESR capacitor and see how it tests in a later video. And if it needs one, I'll end up adding one. Now, the ground is going to be the hardest to solder to because it's all over the board. So it dissipates much better. So it gets pretty difficult at times. So make sure the tip, again, is very shiny before you start, and you increase your temperature to like 450 degrees Celsius to be exact. You need to identify. Now right here it's getting a little bit difficult to identify, and we can see here's a plus and here's a minus, so we'll just follow this one. So this is going to be our ground right here. So what I'm going to do first is I'm going to heat up the pad, and obviously you want to make sure you have the solder on there first. I want to heat up the pad, then bring in the wire and just hold on the wire just slightly like that and start adding solder. and that will allow it to start transferring the heat much better. And as you can tell, it's already started to melt. Make sure we have the wire into place, and we'll let that go, let it cool for a bit, and that should get it good. Yep, there we go. We have our ground connected. And again, increase your temperature, it'll make your life so much easier. Now let's go ahead and do this. Now again, like, remember when I told you that if you're right-handed, start from the left side? This is gonna get a little bit difficult because again, I am right-handed. And if you have some hemostats or you don't, I highly recommend you get some. Probably gonna use it here. So what you do is just hold it like that, and it'll click into place right here. And now as you can tell, like this, it's holding that for me. So if the wire will get really, really hot, and this will allow me to bring that in much, much better. So let's go ahead and find the perfect position. Right there is going to make my life so much easier. So as I'm heating up, all I have to do is just bring this down and twist it, and it'll be into place there. So again, tip as shiny as possible, put some solder on there, and start by heating it up. Try to have something hold the ESC into place if you're not experienced. The positive side is usually much, much easier here. I'm going to keep that there. I'm keeping pressure with the soldering iron. I'm no longer holding that hemostat. And I'm coming in with my solder right here. Don't worry about keeping the tip on there for a while. Nothing bad is going to happen. I've noticed a lot of new people get scared. No, don't get scared. Everything will be fine. There we go. Now I am actually keeping pressure with the hemostat once I let go. And now we have a beautiful little joint right there. So you go ahead and smoke that now. No, I'm just kidding. So there we go. Now we have a good solder joint. All right. So let's go ahead and bring in our quadcopter and prepare it. And prepare the motors to be installed into the ESC here. All right. So also when you're installing your ESC, make sure it's not touching the carbon on the bottom. That's going to be very, very important later on. So there we go. I'm going to put that like that. I'm going to put this temporarily here so it stops moving. All right, so let's take a look at this. So we can see, well, actually you can't see anything. Now, no matter how much pressure when I tighten the top screws or whatever I tighten, it's not going to touch the bottom carbon. So that's very important. Also, any of this stuff, nothing is touching the carbon fiber, or else as soon as you plug it in, you can risk catching your whole thing on fire. So be very, very careful with that. All right, I think we'll do 1 or 2 motors together, and then we'll skip over this step. So I'm just going to grab the first one right here. And I'm going to go ahead, or let's see. No, let's stick to my rule, which is let's start from the left side since, again, I am right-handed. I'm going to try to keep this clean. There we go. And the hemostats here would come really handy because these do get really, really hot very quickly. So now, make sure the tip is shiny. Bring it in. Melt the solder first, then bring in the wire and melt the wire on there. There we go. It's not the cleanest, but that's going to do the job just fine. There we go. We're going to do the next one now. So remember, my motor wires do have solder, and also obviously the ESC's pads do have solder as well. So here we go. I'm going to heat up the pad, wait till I could touch the pad on the bottom, or heat up the solder until I touch the pad. Then I'm going to bring in the wire and put the soldering iron on top of it until I am satisfied. We'll double check that in a bit. I can't see from this far. Plus, the way that the light is shining makes it look like everything is bridged together with the lighting setup I have here. All right. So it's okay, but I really don't like that one. I might go in and just hit that slightly. You could always add a little bit more solder, just a tiny bit more solder. Now, when I'm going to hit this real quick, since I'm not holding the wire, I'm going to keep as much pressure as possible with the soldering iron. Because if I let go and this flicks and the solder gets everywhere, oh, that's really bad. You don't even want to turn that thing on. So I'm keeping a lot of pressure with my soldering iron right now until I come back and I hold the wire into place. Make sure you do not let go of these wires, even if they're hot, because if they flick, you could just mess everything up here. And that has happened to me before. So also tweezers are very useful as well for this setup right now. All right, so we're gonna do the same thing. Maybe I'll grab some tweezers, or you know, we'll grab the hemostats here. So I'm gonna grab these hemostats again. I'm gonna click it right there. So now it just makes things so much easier for me to work with. And I have leverage and I have control. All right, and I don't have to worry about burning my hand. Heat up the solder until I touch the pad. As you can tell, it's a little bit more difficult because my tip isn't shiny. And I should have done that in the beginning, but it's okay. There we go. And then I could just pop the hemostats off. I could grab the next wire. There we go. Go ahead and heat this one up. And we're going to heat up the wire on top of that. Beautiful. We can pop the hemostat off. And now we're going to go ahead and grab the last wire. And I think we're probably going to skip the next step. Or not the next step, skip the other 2 motor wires there. All right, and that looks really great. Looks actually really good. So it's not the best, but it's good. It's good enough. So now we're going to go ahead and jump into the next step. So I'm going to finish these up real quick, and then I'll be right back after that. All right, so now we're basically complete with the ESC. You could actually turn off your soldering iron actually now. We're basically done. So let's go ahead and see how everything's gonna fit, because there's still a little bit more to get right here. For example, right now, if I were to put this flight controller right on top of the ESC, some of these components are actually going to touch the ESC. So let me show you that real quick. Luckily with this stack, they give you so many rubber O-rings and shock absorbers and gummies and stuff that it's actually going to be very useful. So as you can tell, that capacitor right there is touching one of the FETs. And we don't want that, because that could also translate vibration. Not only that, it could also possibly cause a short circuit, which is a really bad thing. So here, they provide you with so many rubber O-rings here. I'm going to put 2 of these on each screw right there. And that should give us enough. Actually, it should give us a lot of clearance. I've already prototyped some of this stuff before I started the video, just to make sure everything will be perfect for everybody, and make sure you'll have just about everything you need in order to get it to work properly. So now we have those O-rings into place. And once we put this in, let me show you. Okay, just make sure the screws don't come off. So now we have much more space. As you can tell right there, there's a huge space. Hopefully you guys can see that. It's really difficult on my small camera or small camera screen. So yeah, anyways, we have plenty of clearance. I'll get another product shot later for you guys. All right, so I'm just gonna put the screws into place. First, I wanna make sure, my wires are in the correct place. So now it just becomes into basically like a puzzle piece. So here's the receiver. Now again, it's very important to install the ESC wire and make sure you do it correctly here. All right. There we go. Okay, that's into place. I'm gonna grab my camera wires, make sure they're in the front, along with the video transmitter for now. I'm gonna bring it off to the side here, and then I'm just gonna put it right into place. There we go. Really nice. So now that it comes with these clear nuts here, we can put those into place. Really nice. They look like glass. They're actually plastic. There we go. Just gonna put them in temporarily. I'm not gonna tighten them too much right now, and just so the screws don't fall off that we have on the bottom, because there's really nothing else holding them. Now you can see your stack is kind of it's basically damped here from vibrations, which is going to be very useful. Okay, so now the next step is we can do with the video transmitter 2 things. We could kind of tape it down to the back of the frame, or you could use these mounting solutions. What's really nice with this frame is we could also use these mounting solutions. However, if you do decide to do that, you need to buy yourself a little pack of standoffs, which you should definitely always have, especially if you're going to be building a quadcopter, or even if you have one. Those last really long. I'll show you what they are right now when I go grab them, and you know, you'll be able to use them on stuff like this, or if you break something, you could kind of replace them. They're called nylon standoffs. That's what we need. So I'll have some of those linked down below. Let me go ahead and go grab mine. All right, so I've gone ahead and grabbed the nylon standoffs here. They come in a pack like this. This pack has lasted me like 3 years. And I still have it, and I still have like 4 more packs that I've never even opened. So let's take a look at what I did here. So again, this has a double stacking solution. Also, this video transmitter has a 30x30 or half a 30x30 stacking solution right there. So if we take a closer look here, you can see I've gotten just some of those standoffs, and I put them right there, and just some screws on the bottom. And now I can just easily place this into place just like that right here. And I'm going to grab a couple more standoff. I'm going to grab these instead of the nuts. And the reason why I grab these big ones is because it's going to make it easier for me in the field to tighten and make sure they're tight, instead of having to play around with a really tiny plastic nut, if you might say. This just gives you better grip to twist these into place much better. You don't want this coming off while you're flying, because you'll lose video feed, obviously. And that could be pretty bad, actually. All right. There we go. We have our video. Now our receiver is left. I really want to do the receiver under the video transmitter here, but what I'm going to end up doing is probably just taping it to the top part of the frame. But as you can tell, this is exposed right now. Usually these come with clear heat shrink, but this has been salvaged from another frame. So I'm going to make sure it's bound, and after that, then I'll just put tape around it. So I'm just going to put this to the side for now. So now I'm going to go ahead and grab my camera. Also, yeah, something you might have missed here. This is a 3D printed fart. 3D printed fart. I get... This is a 3D printed part I get from Thingiverse. I actually print quite a lot of them, and it just makes your life so much easier when you're going to set up this XT60 right here. As you can tell, it goes right into the standoff, and I'll have that link down below. They're very, very useful. There's also another variant which comes with a smaller hole, but that you'll have to use it before you actually solder your wires, because that should just hold the motor wire into place. So I highly recommend this one. It's much better, more flexible for you. So let's go ahead and do the camera now. So we're going to need the camera plates. And here we have the camera plates. So let's just move the quadcopter to the side for a little bit. We have the camera, and we also have the camera plates. Now what's really nice with the camera, they do provide you with the screws needed. And if you get the same exact camera, then you're going to use a 1.5mm hex driver. Now let's hope the screws are long enough to make it through the hole though. Oh, it is. And that's what she said. So there we go. So now we have our motors or camera screw right into place. So I'm just going to keep my hex driver. This is 1.5mm currently. And usually the connector is up top. So when you're going to put this into place, if you already know the orientation, actually, if you're doing the same exact build, then this is the top. So if you're doing the same exact build, this is the top and that's the bottom. And there's the connector, and all the writing seems perfect. So I'm going to go ahead and grab the biggest screw in here, and we're going to do the same thing to the other side. There we go. And here's our screw hole. I wish it wasn't raining. I would go take it out right now. Okay. And then we're just going to, the rest is just going to go into itself, kind of like a puzzle. So I'm just going to twist these wires just like that. It'll make things a little bit better for us. There we go. Okay. It'll just wrap in on itself, keep everything tucked away very nicely. Okay, camera's into place. Just tuck this in. Receiver, we're gonna keep that hanging for now. Now the upper plate, this is the video transmitter thing that I was telling you about, the antenna, the Rush FPV antennas. So if we grab a closer look, these are the plastic pieces they provide you with right here. And there's a nut right there that goes right in there flush. And they also give you the screws for this. So that's why this fits there so nice, so you don't have to worry about mounting your video transmitter's antenna. Bam, just like that, we're mounted, and we could actually plug this in now. So I really didn't look into what is the best way to do it in terms of not allowing a lot of stress to stay on the wire. Actually, no, it's not bad. Oh, that's not bad actually. That looks pretty good. Okay, so now like this, what I'm going to do with the receiver later on is I will go ahead and strap this in the back, and that's really it. Right now I'm just going to begin binding and doing the process of recording that video and releasing it later along with the flight footage. So let's go ahead and put the top plate on, and we'll see what else we need to do. So we can see we have still a lot of space available for us. So if we had some kind of a split camera, we could even add that in here. I wanted to add the run cam split 4, but the wire was way too short. So that's why I just ended up going normal. Now you can see the space between the flight control and the ESC, which is going to be plenty enough. Maybe if we just use one of the rubber O-rings, that would have been just fine. But here we ended up using 2, which again is also good. Now for the receiver here, I just did a temporary hold just to give you an idea of how I'd set that up. I put some tape just to hold it into place. Obviously it's still exposed, and never do this. I'm not going to boot this up right now. I still need to bind it and prepare it. And I still need some 7-inch and 6-inch propellers because I don't have any. I broke all of mine. So yeah, so I'll just end up taping the receiver up here, or even on the bottom. I think on the bottom would be better, because as you can tell, when I routed the receiver's antennas, it's coming from the top all the way to the bottom, which is really not a good thing. I really don't like how exposed those wires are. So it'd probably be better to put it on the bottom part of the frame, or tape it to the bottom, and maybe raise the video transmitter up a little bit more, so I don't have any interference between these two. Not that they usually never have any interference, plus this has shielding. But yeah, I'd probably just take that to the bottom and not the top. So if you're going to do that, put it on the bottom right there. And anyways, this is going to get a TBS crossfire receiver for long range later on. But right now it's just a testing rig currently. So everything is linked down below, and the flight footage will be out along with the DJI budget build. I did fly that the other day, and it was actually an absolute beast. It was basically the same frame, but the 5-inch, and it was just the HD setup, super budget, and the thing is an absolute beauty. So yeah, if you guys want to see the setup guide for this also, let me know. I might incorporate that into the flight video, because those never really get any views, so I don't know if you guys even care about those. So if you want to see that, let me know. And everything is linked down below if you could check those out. Those greatly support the channel. If you have any issues, check out Ask FPV. It's on Android and iOS. Again, it's Ask FPV. Everything is linked down below. All the components, all my tools, everything I used, even my soldering iron, which you should definitely check out. I'll have linked down below, and I'll see you guys in the next one. Peace.